this gave me the first biggest step of my career life. I wouldn't be where I am today if I hadn't done engineering.
I wanted to be an engineer since I was a kid.
I hope it will help me to offer solutions to the problem in the future and to the problem in the world out there.
Engineers are problem solvers. They make a difference in people's lives using technology. For Kenya to achieve the Big Four agenda, we need more engineers to provide engineering solutions to technical problems. That is why the University of Nairobi's Department of Environmental and Biosystems Engineering has continued to provide the best curriculum that prepares students to tackle global challenges.
And the choice of technology.
The University of Nairobi is a premier institution in the training of engineers, and to carry out this mandate, we have 5 departments. The Department of Civil and Construction Engineering, where we offer a degree in Bachelor of Science in Civil Engineering. We have the Department of Electrical and Information Engineering, where we offer a bachelor degree in Electrical and Electronic Engineering. We have the Department of Mechanical and Manufacturing Engineering, where we offer a Bachelor of Science degree in Mechanical Engineering. We have the Department of Geospatial and Space Technology, where we offer a degree in Geospatial Engineering. And we have a Department of Environmental and Biosystems Engineering, where we offer a degree in Biosystems Engineering.
This college is very key to this country's industrialization and transformation towards a middle-income country. One of the things which this country is also now pursuing is the Big Four. Now, if you know now the Big Four, they are almost again very relevant to us. Manufacturing is one of the Big Four. Areas of food security is one of them. Issues of housing is one of them. And even health.
The department started as a Department of Agricultural Engineering, but with time, it evolved to the Department of Environmental Biosystems Engineering. The name change from Agricultural Engineering to Environmental Biosystems Engineering came about through a consultative forum that we had in 1997 at Kasarani between the Faculty of Engineering and the stakeholders from industry.
The bachelor's program is structured to be completed in 5 years.
In our department, we see ourselves as a key enabler of Kenya's industrialization process, and Kenya needs to industrialize, and all of us are aspiring to grow into an industrialized country.
Our admissions are normally in September of every year, and we admit students who have completed the KCSE and have shown excellent performance in the areas of technical subjects, especially in physics, chemistry, mathematics, biology, and geography.
Students study life sciences and ways in which biological systems interact with the environment.
We anchor the biosystems engineering elements, where we basically focus on manipulating the land, the air, and the water systems so that we create a conducive environment for the production of food and fiber necessary for human well-being. Now, that manipulation of land, water, and air, which we call the biosphere, giving us that bio part of the biosystems engineering, is what we focus on.
When we come here to Apakabete, we actually tackle the real issues in engineering, and We actually develop some prototypes for engineering. We do projects and we also do some research.
Over the years, there has been an increasing number of female students enrolling for this course.
Engineering has been known to be a male-dominated profession, but currently there are so many women who are enrolling into the department, and they are doing quite very well.
Last year, but one, we had about 7 to 8 first-class honors, and all were ladies. And in the group that has just graduated, we've also had about 8, and of that, about 6 are ladies.
Engineering basically is using mathematics to solve real-life problems. And we do classes and lectures, and we also do labs because this is engineering, it's a practical course. And the labs are fun. We do soil labs, we do power and machinery, we do woodwork, we do metals.
The department is a world-class leader in training, research, consultancy and outreach in the area of environmental and biosystems engineering. This has attracted both local and international students.
I really met very nice lecturers, and all the lecturers and the staffs at the department are very cooperative. They helped me in solving each and every problem that I came through. And the chairman by that time was the first supervisor of my thesis. The title of my thesis is Modeling Variable Cost of Tractors, a case study of 10 tractor models in Juba of South Sudan.
It is a highly dynamic and market-driven course whose curriculum focuses on 5 main thematic areas: environmental engineering, irrigation and water resources engineering, power and machinery engineering, food and processing engineering, and structures engineering. Our health is related to the quality of environment we live in. Environmental engineering is a branch of applied science and technology that addresses issues such as energy preservation, waste management, pollution, public health, and environmental impact of construction projects. Students are equipped with skills and the knowledge to create sustainable and environmentally friendly alternatives to what we already have.
In our department, wastewater is not a wasted resource, but a resource that we plow back into production. For example, in biogas and in water for non-potable uses. And that makes environmental engineering one of the key subjects in our profession.
We seek to exploit the natural resources, particularly soil and water, in agricultural production for food and fiber security. We do this in a sustainable manner. We are looking at utilizing these resources in a manner that they will remain useful for our children, grandchildren, great-grandchildren, and even the generations to come.
We need to transform the agriculture sector from a low-income, low-efficiency, and low-technology sector into a vibrant, modern sector that supports value addition. It is estimated that about 30 to 50% of food in Africa is lost after harvest due to lack of food processing technologies.
We produce coffee, but we just export it as raw beans. We produce tea, then the tea is packaged somewhere else. It comes back to us in packages, which we buy even more expensive. That department is really the answer, because there are technologies which they are experimenting on. Their laboratories can show this country how to do value addition, how to do transformation of agricultural produce, so that there is agro-processing.
We are well equipped to train this area. We have a well-equipped laboratory with processing equipment, what we may call laboratory scale equipment for training. We have got lab scale processing equipment, lab scale rice milling equipment. We've got drying equipment, in the labs. We've got hoggers for grain storage and so on and so forth. So we've got a well-equipped lab and the staff to train the students.
Biosystems engineers are also prepared to work on projects that require engineering involvement through structural design and implementation, such as greenhouses, storage structures, and animal structures. Food security is the major output of irrigation. However, this cannot be achieved without sustainable water management. Biosystem engineers design systems that supply water for irrigation to thousands of hectares of land.
Basically, there are three main areas of study. One is the water systems, where you're dealing with how to capture, transport, distribute, and use that water resource. The second one is the irrigation, where you are looking at how do you plan, design, implement, and operate those irrigation systems. The third one is the drainage system, which is basically involved in the process of establishing where are the places where we are having excess water problems, how much excess water is getting to that area, what are the economic losses associated with that level of excess water, and then how do you effectively and efficiently handle that problem. We do this by applying engineering, biological, and human principles and practices so that we can deal with it in a much more holistic manner.
Margaret, an alumna of this department, has been working for Davies and Shetley for the last 20 years. The company supplies water equipment such as water pumps and irrigation systems in the East African region.
My mathematics teacher was so impressed by my performance. I was very good in mathematics and in physics. Basically subjects that lead to qualifying for an engineering course. And he planted a seed in me. He said, I think, Margaret, you should be an engineer. You're a very bright student. And that inspired me. And when I got to Form 4, before I sat my Kenya certificate of secondary education exam, I filled in engineering as my first choice. And I was blessed, should I say, that I qualified very well for my dream choice, which was agricultural engineering. And I was admitted to my choice university, which was the University of Nairobi, a very prestigious organization, one that I hold dear to, one that I still look for inspiration from.
She started working for Davies and Shetley almost immediately after her graduation as a sales engineer.
Davies and Shetley is a company that sells technical solutions. So you cannot sell something that you do not understand. You need to understand the products. And we are majorly known for water, especially then, but we are also known for providing energy solutions, especially green energy. We are big on solar solutions. And so in our many segments, we do water pumps, borehole solutions, swimming pools, water treatment solutions, solar pumping, solar heating, generators. As you can see, as I talk through this, you realize that these are technical equipment, and for you to be able to size or design a solution for a customer, you must understand the equipment that you're selling. And there's a lot of engineering in formulating the solutions.
Irrigation is one of the areas that benefits most from solar energy, especially in the arid and semi-arid lands. Solar energy is renewable and sustainable, making it a highly appealing source of energy for use in the farms. Students learn how to utilize solar energy by making solar-powered equipment and machinery.
As the population increases, water is becoming a big issue, the scarcity of water. So we are looking at systems which improve the efficiency of the application of this water. Of course, we have been involving all the years from the surface methods, sprinkler methods to the drip. And now beyond drip, we are focusing on what we call smart irrigation systems.
Man is a machine, no doubt. He is a marvelous piece of work. The only difference is that man has got life and consciousness which machines do not have. Machines are time-saving, cost-effective devices that are responsible for industrial economies. Mechanized agriculture encourages large-scale production and improves the quality of farm produce.
And a lot of my research work has been on power and machinery design in their use of power. So how they use power, the whole new thinking has brought us into that thinking, because we need to be able to use it efficiently and minimizing in waste. So the underlying theme in the research line is sustainability and efficiency. So we're looking for tools that use less energy and are effective in giving you the soil environment that you need for planting, that you need for soaking in water, and many other things that we need to do in supporting the production system.
Students are equipped with practical skills on the operation, maintenance and repair of heavy machinery. At Ekule Farm in Narok County, Kipruto, an alumnus of this department, has been applying his skills and knowledge to increase production and productivity in the 700-acre piece of land.
The skills I gained at the university include water harvesting, soil conservation, machinery, farm power and machinery, also irrigation. And these skills are very important for a farmer or at farm level. I've utilized these skills in especially Kenya Rainwater Association, where we are advocating for rainwater harvesting for over 20 years in Kenya. I've also used this in the field in different countries, in Kenya, Uganda, Tanzania, Somalia, and in all these it's mainly to deal with water management and also environmental conservation. I joined Erokle Dairies Limited in 2014, and this is where I've also practiced my skills in a big way through doing best practice for hay production.
He has brought a lot of value to this project. He is quite good in machinery, so most of our operators do not match him, so he acts like a supervisor of the operators. He acts like my assistant and a colleague when it comes to agricultural knowledge, and we put our hands together, and that way we have worked as a team, and we make better decisions when we are two of us than when I'm alone.
Clearly, this department is not only producing engineers that study the world, but engineers that are also changing it.
Apart from training undergraduate, we also train at postgraduate level, where we have master students and PhD students doing research in those areas to try to maybe help our country improve as regards food security and housing of crops and animals.
It was a good choice to study here at University of Nairobi. I've met very qualified staff who have assisted me, from the technical to my lecturers. I've also had an opportunity through the collaborations that the university has with other universities like ETH in Switzerland, ICPE, where I've been actually carrying out my research from.
And our graduates normally get employment across all those boards, be it the processing industry, like the milk industry, tea industry, coffee industry, among others. So you'd find them being employed in government, in the private sector,
or international organizations like ICRAF, UN, UNEP, we have our students in all those places.
So when we look at revolution in the world, from the agrarian revolution through to industrial revolution, capital revolution, and now knowledge revolution, our department, which basically is now knowledge driven, we are using knowledge to spur agricultural revolution at the production level, which will provide the products that will manufacture at the manufacturing level to position us to gain the income we require for capital investment and knowledge growth. So we are the department for the moment, not only for this country, but for this continent.
It is a center of excellence in undergraduate and postgraduate training in environmental and biosystems engineering that is contributing significantly to the attainment of Kenya Vision 2030.